Hello everyone and welcome back to the channel. In today's video, we are going to be taking a look at a very important machine learning metric called the mean absolute percent error. This metric will help you analyze and determine which model fits your data better, and it will help you compare different models. This error metric is used to tell you the goodness of fit of your machine learning model to your data. So we're going to be taking a look at in this video how to build two machine learning models, that is the linear regression model and the log model, and compare which model better fits your data. You can use this concept for any other machine learning models as well. And this is going to be a regression problem statement, so stay tuned till the end. But before we dive right into it, do not forget to subscribe to my channel for the latest of data analytics across different technologies. And we're also going to see why this model is very important. So let's take a look at the video. So this is my data set. We have considered only one x variable or the dependent variable and only one target variable, so that we understand this concept clearly. But this concept can be applied to any number of dependent variables and the target variable that you want to predict. Okay, so the concept remains the same. So let's take a look at it. So I have the sales of a particular company as a function of the advertising spend. These values are in thousands. So for example, for a 5,000 spend in the advertisement, I get a sales of $20,000. Similarly, for a spend of $25,000, I get an actual sale of $107,000. So let us see first if there's a relationship between the advertising spend and the sales. We can model this. Let us select this area, click on insert, and let us select a scatter plot. So you can see the scatter plot shows us there's some kind of relationship, but let us make this more clear so we can understand better. So I'm going to first do some editing. Let us go to click on the axis, and this is the spend. Okay, so that we understand it clearly. So this is the advertising spend, and here we can see this is the sales. So we can see now the sales keep on increasing with the advertising spend. So let us try to model this data. I'm going to click on chart design, and I'm going to click on add chart element, click on trend line, and let's select linear model. So you can see this can be modeled by the simple linear regression model. And let us take a look at this model. Okay, so I'm going to click on this line, okay, and click on this, and now let us say display equation on your chart. So this is my simple linear regression model. Simple linear regression model is of the format y is equal to b1x plus b0. So these are your b1 and this is your b0. Now let us see if there's any other model that better fits this data. Okay, so I'm going to click on chart design again, and I'm going to click on add chart element, trend lines. This time click on more trend line options. So here you can see, if you click here, there are different types of models available. You can see the curves each model show. So in this case, let us try to see logarithmic, because it shows a better fit, as you can see here, and you can see this. Now the problem is, you can see this here visually, but if there are multiple x variables, as I explained, then it's difficult to visualize this in a two-dimensional space, right? So that's why we need to use a metric to actually tell you which model is better. So let us get the equation for this model as well. I click on this, and this is the equation for my log model. Now I want to compare which model is better for making predictions and which will better fit my data and help me understand how my sales will vary as a function of my advertising spend. For this, I'm going to do the predictions using this model, and then we're going to calculate the mean absolute percent error. So let me copy this down. Okay, I'm going to be pausing the video after some time because I'm going to make some formatting. I don't want to waste any time. I'll make the formatting, and then we will see how to calculate the different mean absolute percent errors for the different kind of models, right? Okay, I'm back now. So let us see the table. So here's the table I've created. This is the linear model. This is the log model. I have columns for predictions, absolute percent error, and the predictions for the log model and the absolute percent error. Now I've written the linear model as y is equal to b1x plus b0, where b1 is the slope and b0 is the y-intercept. I like to write it using this notations because if we have multiple dependent variables, then I can write it as b1 of x1 plus b2 of x2 plus b0. Similarly, if I'm doing a regression of the higher order, say polynomial regression where I want to fit a non-linear curve, I can use this notation very easily. So now let us copy the b1 and b0s for the linear and the log model respectively. So b1 in this case is nothing but 4.4702. So 4.4702, and the b0 is nothing but 4.8 348, and in this case in the log model B1 is nothing but 58.41 and B0 is nothing but minus 79.803, right? So we have got the two models. Now let us try to make predictions. So in this case the model is y is equal to B1. Let us fix this by hitting F4 because you don't want it to move down when you drag it down into the x variable plus the B0 value. Let's fix this as well. Hit F4, enter, and these are your predictions. Let us drag this down. Now let us calculate the absolute percent error. This can be done by using the absolute function, and now do the predicted values minus the actual sales, close the bracket, divided by the actual sales, and this gives you the absolute percent error. Let's drag this down. Now let's do some formatting to make it more clear. Click on the percentage and then give it a single decimal. So now we can see. And similarly, let us make the predictions using the log model and then compare both. So in this case, y is equal to B1. Let us fix this. Hit F4 into natural log can be given by the function ln in Excel, and give the x variable, close the bracket, and plus B0 in this case, that is minus 79.803. Hit F4 and fix it, enter, drag it down. These are your predictions, and the absolute percent error can be calculated once again. Do absolute and click on the predictions minus the actual sales, which is the actual target variable, divided by the actual sales, which is the actual target variable. Drag this down and let us give the formatting percentage and give a single decimal. Now I want to compare the mean absolute percent error, so I'll simply do the average. Okay, and you can select these values and you can see the average error is 10.9%. So the average error in the predictions from the actual target variable is 10.9% here. In this case, in the log model, so you can see the actual error is only 6.5%. So you can see the log model is good. However, this can be deceptive at time too, because as we have seen in my earlier video, the average are or the mean is sensitive to outliers. So if there are extremely high values here, it can the mean can be sensitive to that, but the median is not sensitive to outliers. So let us try the median value as well, just to be sure that this model is better. We can then do more analysis. So let's select this. The median of the absolute percent error is 7.9%, and for this one, for the log model, the median is 2.5%. So you can clearly see even the median value state that the log model will give you a much accurate representation of your data, and the log model is better used to fit your data. This can also be seen from here, which can be represented visually, but as I said, this can only be seen in a two-dimensional kind of data. If you have a multi-dimensional data where you have more than one x variables, you have 15, 20, 30 x variables, and you're trying to predict the sales as a function of that, it's very difficult to depict the representation visually in the multi-dimensional space. And that's why you can use this metric, the mean absolute percent error, to tell you which of your different models better fits your data and which model will give you better accuracy by making predictions. I hope you like this video, and if you did like this video, leave a comment. It helps me make more videos, and leave a comment on which type of videos you would like to see, and do not forget to like this video and subscribe to my channel for the latest of data analytics across different technologies. Thank you.